welcome to another edition of Intercept U, our continuing series on high efficiency, high performance buildings, and specifically with the use of Intercept SIPs and things that we can learn through our discussions of how to make a building more efficient and something usable and user-friendly. Today, we have Joe Pasma here. He's our National Sales Manager for Intercept, and we're going to talk about an area of the building that is often overlooked. We talk about building a high-performance building, and there's so many aspects of it. There's no one feature that fixes everything. Now, SIPs are the feature that we always talk about, but even within that, there's one area of the building that's often overlooked, and that's that rim joist or sill box area, the area between the basement and the first floor or the first and second floors. And it's an area that is something that needs to be addressed. As I mentioned, it's often overlooked. Joe, maybe you can explain, first of all, what's the traditional way of handling that area?
Well, John, typically when you are stick building a wall, say you want 8-foot wall heights, so the studs are cut to close to the 8-foot height. They're stood up, and then the installers, the framers, will actually put their floor trusses or their joists on top of that wall. So similar to the picture behind you where you see the double plate on top of the wall, stick frame wall is going to have a double top plate like that. And the floor joists or the joists will then, what we call bottom chord bear on those. And there'll be a thin rim board that's used on the outside of the floor trusses or the joists to sort of stabilize them. They're nailed through the rim board to the floor truss or the joist. And then the subfloor for the next level is put on top of it. And you continue on with your building. And you can do that off of a foundation wall or 2-story, 3-story buildings. So you'll see that when you drive around your neighborhoods, you'll see a band, if you will, that looks a little bit different than the wall sheathing above and below that. It could be discolored, or the orientation of the material is a little bit different than what's above and below it. And that's typically that band. The challenge that you have with that, as an afterthought, is that the contractors, the builders, installers then have to come back in and seal that up and insulate it. And if you look at the details associated with those rims, there's all kinds of nooks and crannies and crevices that air infiltration, exfiltration can occur, and that can also be a spot for heat loss, or in the case of air conditioning, heat gain from the outside. So it becomes a real problematic area. A significant amount of energy can be lost there. Some studies are saying that it's upwards of 20% that you can lose through a wall system just through that rim cavity. So it's an area of concern for sure.
So what you just described is traditional platform construction. Building that wall, setting the floor on top of the wall, whether it's the basement wall, we can be talking insulated concrete forms, or a poured basement wall, or a SIP panel wall, or subgrade panel wall, that then the floor is built on top of it. Now, and then the next floor goes up from there. Now, you mentioned numbers can be upwards of 20% heat loss in that area, and we'll stick with heat loss because that's the one that we talk about the easiest. But of course, it also applies, as you mentioned, cooling or heat gain in the summer. So that's a big number. That some studies show up to 20% lack of efficiency there. Have you found that to be the case in the real world?
The way that it's shown in the real world is actually at this time of the year when temperatures are starting to change, and in the spring and the fall, when you have cool surfaces and you get condensation on the outside, you can see that. That's sort of nature's thermal imaging camera, or you can take a thermal image camera and shoot the outside of the wall, especially in the wintertime when it's cold outside. It's really easy to see. Usually with thermal imaging cameras, red is hot and blue is cold from a color standpoint. And when you look at those images, you see the walls are a little bit bluer, which means they're cold, especially well when you're standing outside taking the thermal image. But then you look at that band joist, rim joist, that separation layer between the two floors, and it has a tendency to be more yellow and red in color. And that's indicative of heat loss when you're outside and it's cooler out. So you can see that. So, yes, the answer to the question, that was a long-winded yes. You can see the difference. It does make a big deal difference.
Okay, good. Thank you. So it's something that needs to be addressed. And as we mentioned, it's so often overlooked. Well, why is that? Why is it that so often it's an afterthought how we're going to handle that rim joist or sill box area?
Well, I think it goes back to how homes and buildings are typically constructed. Bottom chord bearing is just been around for forever. When we started with floor joists, or and you're using dimensional lumber as the floor system, they would stand the walls up, put the floor system in place, and go again. And then they go, oh, well, look at all those holes there, and they started adding the band joists, and then as we insulated the walls, it was a way to infill all of that. So it a lot of it is just a little different way of thinking, and you actually have to pre-plan that. If you go to the lumber yard and buy, send me a bunk of 8-foot studs or whatever the number is, it's really hard to extend them another foot and a half, 2 feet, whatever the thickness of your floor system is, to make it nice and solid and insulate it and hang everything off the inside. So that gets to be an afterthought kind of a thing as well.
So you're starting to fade into solutions, and we're going to talk about solutions and ways to address that. You and I both have a very similar background in many years of building SIP houses. And I don't know about you, but I often found that when I would ask the contractor, I would go in just as an installer a lot of times, to just go in, just erect the SIPs, and then turn it back over to the GC. And when I would ask about what are you going to do with that sill box area or that rim joist area, hadn't thought of it. Again, that was just something that, well, we're going to do what we've always done. And they were very excited, especially if they were a new SIP user, very excited about the efficiency of using structural insulated panels. And they get excited about the way Intercept builds this ready-to-assemble package and how that's going to affect the entire building. But in all of that, they hadn't thought about that area that has no insulation at all between the floors. And it's very easy to overlook because it seems like, well, we're going to do that the way we've always done it. SIPs, the rim joists, they don't think of that as being part of a SIP solution. And so that's just going to go back to what's always been done.
In those situations, John, when you pointed that out to them, say they were using the SIP wall for that first floor, and it was a two-story, maybe it was a slab on grade, and they're going to do the second floor, and then they look back and they go, oh yeah, I sort of blew it. I could have done something better. In your experience, how did they rectify that? What did they do to seal that rim joist up after the fact, after the cows got out of the barn, kind of a thing?
Yeah, typically speaking, at that point, they recognized the need to spray foam it. That was the most efficient afterthought way to handle it. And it's effective. We're going to talk about some other areas that we feel are more effective, but really there is a time and place for spray foam. Often people would get a hold of me when they're doing a remodel or an upgrade to their house, and they would talk to me about trying to put panels on it, and it just wasn't cost effective. It didn't work. There's a place when if you're going to open up the stud cavity to use spray foam. But in new construction, when you have this option of doing it from the beginning as a high performance building, there are better ways to address that area. But generally speaking, that's what they would do down at that point. The old fashioned way was just to stick fiberglass bats in and call it good enough. But that goes to the thermal imaging that you're talking about and the leaks, the air leaks, and air infiltration, and they knew if they had made the decision to go with a high performance building like an Intercept SIP package, they knew that that wasn't the way to fix it.
I've also seen people on remodels, homes that were built back in the 30s, 40s, 50s, whatever, where they have lumber, dimensional lumber for the floor systems. They would go in and purchase multiple layers of rigid insulation and cut it to fit into the cavity, and then use the spray foam that you put around the window to seal that insulation in place. And depending on what the R value of that rigid insulation is, and it works, it's relatively effective, but boy, oh boy, is that a time
Labor intensive.
money drain. Exactly. I mean,
Yeah.
I can't. And then how do you get into the spots behind your furnace down in the basement when that big octopus is in the way with all of the ductwork feeding everything else in the house? So yeah, it's a challenge to say the least.
So let's talk about solutions. We've talked about the problem. We've talked about why it's important, because there can be a great amount of heat loss there. So what are the options? Whether it's, again, over insulated concrete forms, ICFs, or between levels, first and second floor, how do we start to address that area of that rim joist area and solution?
Well, I can address both. I'm going to start at the ICFs, or the foundation, first. On the addition that we did on our house, we used ICFs for the foundation, and we had 9.5-inch I-joists for the floor system. So I happened to use Intercept panels at the time we did our addition, and I had the plant make a little mini panel, mini in the sense of height. It was 9.5 inches tall, 6.5, a nominal 6-inch panel. I had my ICFs wide enough that I could put the 6-inch panel on the outside. That acted as the rim, if you will. And then I dropped my I-joist inside, fastened them to the sill plate, and it worked out really well. Subfloor over the top of it, and then went up from there.
The 4-inch panel?
No, I use
Oh, you
six,
just okay.
but four will work as well. Depends on where you're at and what you want to do.
How much room you have on the top of that wall.
Yep.
If it's a poured wall, it's going to be a challenge to get a 6-inch panel. But
Exactly.
an ICF wall works.
In that situation, the nominal 4-inch panel would be perfect for that. And you're still looking at an R16 or 18, which the code is R10 for that area.
And on top of that R value, the air infiltration aspect of it, the air leaks aspect of it is virtually eliminated, I guess.
Because we can get the long panels.
And it's the solid foam. Yeah.
Yep. Exactly. So then once I did that off the foundation, put the subfloor in, then I had the wall panels. We do have a second floor. So I had the wall panels, 8-foot tall walls, and we used, I think, 16 or 18-inch I-joists for the floor system. So I had the panels extend up another 16 or 18 inches to what would be the underside of the subfloor. And then on the details on the walls behind you, where you have the top plate, the cap plate, on that cap plate, we would put a top flange hanger that would hang on the inside of the wall system. And then you drop the I-joist or floor trusses in, and there's still bottom cord bearing, but that bottom cord is bearing on the hanger, the metal hanger, and then the subfloor goes across the top. So really, you're minimizing the amount of thermal bridging that occurs at that detail. And the cool thing about it, people will ask, well, why not just balloon frame the walls? Because we can make the walls 24 foot tall. The challenge with that is I'm only 5'6", so trying to stand up a 24-foot tall panel when you're that short and hold it into place and get everything in there can be a little bit problematic. So what I've found through my experience is that the top flange hanger gives you the benefits of reduced thermal bridging, like a balloon framed wall, but it gives you the advantages of platform framing, where you're framing just a level at a time. And from a structural standpoint, the reason that I like the top flange hanger is that the subfloor then can extend out over the top of the cap plate, and you're nailing down through the subfloor into the cap plate. and those walls down below act as shear walls. So your diaphragm force transfer into the top of the wall is really efficient, and it's just part of the installation process. So from my standpoint, that worked really well on the projects that we would install.
The first time I did that, the first time that was presented to me, this idea of hanging the floor joists in top flange hangers, to me, I was afraid of it because it felt like really you're hanging the whole floor system in hangers. That's what's carrying the load. And you being a structural engineer, you get this, and it makes sense to you. But that whole process was then explained to me that with the subfloor going all the way out to the outside edge of the walls, tying everything together, and with the hangers being top flange, and so the nails go down through that top cap plate and into that top plate into solid lumber, which is already nailed on both sides into the top of the SIP, that it is a remarkably strong system. In fact, stronger than platform construction, because it's eliminating so many hinges. And by setting SIPs on top of SIPs, you've eliminated the entire issue that we're talking about. Now, you mentioned you have to plan ahead. Why do you have to plan ahead to do it that way?
The walls get to be a little bit taller. Again, the wall is extended up whatever the depth of the floor system is, that I joist or floor truss or dimensional lumber that you're using in the floor. So you need to have the plant extend or make the wall panels a little bit longer, which is no big deal. And then in the case of the rim itself, coming up off an insulated rim panel where you're coming up off of the foundation system, well, in both cases, actually, the eye joists or the floor trusses need to be a little bit shorter in length. A lot of times they're measured to out of the wall. In this case, they're actually sitting inside the wall. So that material needs to be a little bit shorter. That's not a big deal if you're using an eye joist or dimensional lumber. Those are easily cut and adjusted to fit that way. The challenge that you run into is that if you order your trusses and you order them 24 feet long and you take off a nominal 6 inches on either side, they need to be something just short of 23 feet to fit in between the 6-inch wall panels. So that's part of that planning ahead that you need to take into account.
Absolutely. And it's worth noting too, when we talk about these top flange hangers, it's very easy to get them for, you mentioned 9.5-inch eye joists, but they make them for 24-inch floor trusses as well. You can use the exact same system with a 24-inch bottom bearing floor truss. And so it's the options are available. One of the challenges I had when I was doing this, because I hadn't met you yet, was running electricity from the top floor to the second floor. Because now, as you'll see in the diagram, our video guru here, I'm sure he's putting pictures up and illustrating this as we're talking about it, which we appreciate so much. But that idea of having one floor on top of another, how do you get the electricity? Well, we made a video about that. You can check out our video. We'll provide a link to that video, as a matter of fact, showing how you can take the electricity and bring it out into that floor cavity area and then take it to your next level. So it really doesn't provide a challenge at all. It's just knowing how to do it, which I didn't when I was installing. So I appreciate you teaching me that method.
The other
Go ahead.
The other thing that I learned, well, two things back to the electrical, it's really just a matter of angling the bit and drilling through the interior wall into that floor cavity. So that's easily shown on the videos that we'll have in addition to this. But the other thing that I learned the hard way on my addition is that when winter came, it got cold out, and I walked outside to look at the eaves underneath our kitchen walls, and there was frost on them. And here I've got this nice tight house that at least I thought was nice and tight with frost coming out, and I couldn't figure out what was going on. And then it dawned on me. That's where we use the top flange hangers. And the top flange hanger is a piece of metal that's just under 1/8 of an inch in thickness. But when you put that on the cap plate and then you put your subfloor on top of it, there's a little bitty gap in there that air can move up through. So I learned the hard way. I had to go back in and spray foam that to seal it up. But what we've done for detailing since then is the same sill seal that you put down on your concrete foundation wall underneath the sill plate can be used in that location when you're transitioning from a first floor wall to a second floor wall. Before you lay your subfloor down, you put that sill seal on top of the wall, staple it in place. So then when you put your subfloor on top of that, you've actually you've air sealed that little gap that gets created because of the top flange hangers on there. So, you know, devil's in the details. And that was one of
Absolutely.
those details that uh, old people are smart because they've made a lot of mistakes. So,
Well, we do keep learning as we go along, and those types of details are so valuable, and that's part of the purpose of Intercept U as the whole program that we do here. This whole idea of talking about this is trying to help pass some of those details along so that individuals don't make those mistakes and really are thrilled with their end product. So thank you so much for this discussion. We want to mention too to our viewers, again, we always encourage you to like and subscribe to these videos, but also don't forget, add comments in the comments section. We do read those comments, and if you have suggestions for things that you would like to see, maybe we've already made a video. We have a lot of videos on the page now, and maybe we've already made one, and we can just shoot you a link to that. If not, if it's something that we haven't discussed yet, let us know and give us an opportunity to talk about it and mull it over and see how we can address it so that you can continue to benefit from it. We appreciate your time, Joe. This was beneficial, and we invite all of you to come back for our next installment.
thanks, John.